Hi, this video will focus on conditional probability. And when you're reading a question, the key word for conditional probability is going to say given. If you see the word given, that means you're going to do conditional probability. And all you really need to know for conditional probability is that you're not going to be using the total for the table. So you're going to find the probability out of that row or that column only, whatever you are given. If you're given something that's a column, then you're just finding and you're only looking at that column. If you're given something that's a row, you're only looking at that row, not the total in the table. And that's really the only thing that's different. So we're just going to go and look at some examples. All right, so this question says, find the probability that a randomly selected person from this group is conservative given that they have attended college. So here's my key word that it's conditional probability. Given that they have attended college. So I go up here and I see this row is people that attended college. So I'm actually going to cross out everything else because I don't care about it. All I want is this row. And now it wants me to find what is the probability that somebody is conservative. So I have 6 conservative people. And I'm, again, only looking at this row, so I need the total for that row, which is 25, 31. And it says to enter it as a fraction, and 6 over 31 does not reduce, so that is your final answer. All right, so this question has results from a survey, and it is very wordy, so I will caution you. It says 38% of people have a pet now and have had a pet, meaning in the past. 62% of people do not have a pet now. 86% of people have had a pet. And 14% of people do not have a pet now and have never had a pet. Right, so I set up this table. These are the people that have a pet now. I had written now down there. These are the people that do not. These are the people that have had a pet in the past. These are the people that have not. So filling in these numbers, 38% of people have a pet now and have had a pet in the past. So 38% is going to go here. 62% of people do not have a pet now. So they do not have a pet now, whether they've had one in the past or not. So I'm going to fill out 62% down here. 86% of people have had a pet. So they've had a pet in the past, whether they have one now or not. And 14% of people do not have a pet now and have never had a pet. So that's going to go here. All right, so I'm going to go ahead and fill in the rest of these numbers. All right, so I filled in this table using the two-way frequency table properties that we've talked about in the past. You wouldn't have to fill in the whole entire table, but I think it's a good practice before your test of just filling it all in. This question is asking for the probability that the respondent has a pet given that they have had a pet in the past. So these are the people that have had the pet in the past, and 38% of them have a pet now. So I'm going to take 38%, divide by the 86%, get that decimal, and then plug it in. Right, so when you divide that, you get 0.44, and I plug that in, and I have the correct answer. So we will move on to the next example. All right, this table is similar. It says, at Kennedy High School, the probability of a student takes technology and Spanish is 0.03. So here I have technology and not, Spanish and not. So technology and Spanish is going to be 0.03. The probability that a student takes technology, so the total technology, is 0.73. What is the probability that a student takes Spanish, given that they take technology? So I don't really have enough information to fill out the rest of this table, nor do I need to. Probability that they are given that they take technology, and the probability that they take Spanish, given that they take technology. So that's out of this row. We're going to use these two numbers, 0.03 divided by 0.73, and round it to 2 decimal places. And when I do that, I get 0.04, which I have entered in here, and it says my answer is correct. So if you don't have enough information to fill out the whole table, you don't have to. If it's given, you only need that row or that column. Right, so for this example, it says the number of discs are placed in a box and one disc is selected at random. Find the probability of selecting a 3 given that the disc selected is green. So I have my table set up for green and blue, and then the picking a 3 and picking some other number that is not 3. So how many green discs have a 3 on it? Well, there's just one. How many green discs do not have a 3 on it? There are 3 of those. How many blue discs have a 3 on it? There are 0. How many blue discs do not have a 3? There are 4. Again, if I add this up, I get 4 and 4 and 1 and 7, and there are a total of 8. Right, so it says given that a green disc is selected. So that means I am only looking at this column. Right, and what's the probability of selecting a 3? So that's going to be a 1 out of the 4 discs in this row. And that's going to be your answer. All right, so this example says, if it rains tomorrow, the probability is 0.8 that John will practice his trumpet. If it does not rain tomorrow, there's only a 0.4 chance that John will practice. Suppose that the chance of rain tomorrow is 60%. What is the probability that John will practice his trumpet? Now, this isn't really a conditional probability example, but I did want to review it. So we're being asked, what is the probability that it rains and he practices? What is the probability that it does not rain and he practices? So we need to fill out this table, and it's going to be an and table. The probability of rain is 60%, so 0.6. Probability of it not raining then is 0.4. And the probability that he practices, if it rains, is a 0.8%. So if I take 0.8 and multiply it by 0.6, that's the probability that it rains and he practices, is going to be a 0.48. Probability that he practices if it does not rain is only 0.4. So if I take this 0.4 and multiply it by the 0.4 chance that it's going to rain, I get 0.16. Now these are mutually exclusive because it can't rain and not rain. It either rains or it doesn't for a day. So I'm going to add these 2% to get the probability that he practices overall. And so when I add these, I'm going to get 0.64, which is the probability that he will practice overall. And I have entered that number here, and it is correct. So once again, if you have any questions with this, ask me in class.